If you are new to the channel, then subscribe the channel. Press the bell icon for further notification. So okay students, in continuation with our earlier lecture, so continuing we'll be starting today the protection of transmission line. That is, we will be starting from page number 20 up to 19 we have already done. So 20 I have newly prepared. So what is transmission line protection? The first philosophy that comes is normal, or that is our overcurrent protection. Whenever your fault current crosses a threshold value, the line should trip. So that's what they are saying. The philosophy is simple here. Compare the magnitude with respect to threshold. You will set a value. If it's crossed that value, then you will say it is overcurrent is flowing, so fault will occur. Otherwise, no fault. So broadly classified, there are two types, non-directional and directional. So non-directional means it will only sense the magnitude. It will not consider the phase angle. It will see the magnitude. If your magnitude is greater than your set point, then it will trip. Otherwise, it will not trip. But in directional, it will also sense the phase angle so that it can have an idea in which direction the fault is occurring. That means, along with magnitude, it will also consider the phase angle with respect to the relay voltage. You can see the relay is located here. So it will have a voltage sensor or some PT will be connected so that it can know where the voltage is. So then the current, this direction, suppose I am putting the CT in this directional, that means if there is any fault in this direction, it may trip. If it is in backward, it will not trip. Something of this fashion. You can make it either way also. So this is the forward current for it. Because power is flowing, normal power is flowing in this direction. So in case of normal power, the angle will be less than 90 degree, V and I. So this is your forward voltage. If the voltage is less than, if the current angle is less than 90 degree, then means it is going in the forward direction, in direction where the normal power flows. Now suppose during a fault condition, current flows in backward direction. We will see in some cases in ring main system, in double feeding system, where current can go in backward directions also. So in that case, the power is flowing in the reverse direction, that is reverse to our normal power flow. Normal is in this direction, but in fault it is going reverse to that. So in this case, you will find this angle, this big angle. So this theta is known as backward, which will be obviously more than 90 degree because power is here flowing in negative direction. So it will sense the angle also with respect to theta, so that any fault in this direction, that is its normal flow, is known as forward direction, and anything in reverse flow will known as backward fault. So the relay will know the location of the fault, so whether it is forward or backward. So you can make it more selective. You want to make it operating on forward only, then it will operate in forward only. It will sense that current, it will sense current, then it will see angle. Angle is less than 90, okay, it is in forward, I am supposed to trip, so I will trip. If it is in backward, the angle is more than 90, whatever the current it is, it will not look into it. So with this it becomes more selective. Now what are the generally settings in overcurrent relay? So in overcurrent relay, in general, you will have two settings. One is time setting. In general I am saying, because in instantaneous overcurrent relay you will not have any particular time setting. The time setting decides the operating time of the relay, and the plug setting determines the currents required for the relay to pick up. Plug setting in some sort of your threshold value or your set point beyond which you want to trip the, if the current goes beyond that, you want to trip the circuit breaker. So this is the block diagram you can see. This is your overcurrent relay and this is your input current. There is a time setting, there is a plug setting. Plug setting, that is known as pickup current. The name plug setting came from your earlier days where electromechanical relays were there. So there were some plugs. You have to take it out and then again put it inside where you can put that plug. So that's why plug and play. So you have to take something and then put. You have to take out a plug and then put physically. So that is known as plug setting. That's why the name remains plug setting. It's still used as plug setting only. But it is nothing but the threshold value, that is the set point you are trying to fix. And there is a trip circuit. This trip circuit is normally NO. NO means normally open. Whenever fault is there, then it becomes closed. So as you can see, so this is the block diagram. So trip circuit is normally open. Now one important parameter, that is plug setting multiplier. What is PSM? That is also important term in your overcurrent relay. PSM is nothing but it will indicate how severe your fault is. More severe fault, more PSM. We can say the formula is I relay by PS. What is I relay? I relay is the CT secondary current or the current through relay operating coil. How much current is flowing through the CT secondary? That is your relay operating coil. That is, if it is 100 by 5, if 100 ampere is flowing, then through relay 5 ampere will flow. So that is what saying. PS is the plug setting of the relay. That means at what current value you want to set it. That's it. Now if your PSM is less than 1, what you can assume, if it is less than 1? If it is less than 1 means denominator is smaller than numerator is smaller than denominator is more. That means your plug setting is higher. Suppose you are setting for 10 ampere. That means your numerator will be, I relay will be less than 10. Suppose it is 9. So what will be PSM 9 by 10, 0.9. That means your flow of normal current, because your set point is 10, the current is not crossing 10, it is below 10. So that's why if the numerator is less, then it is PSM is less than 1. PSM is greater than 1. That means if it is more than 10, what you can assume? There is some fault. Probably some fault occurred. So higher the PSM value, higher the fault severity. More PSM means if your secondary is now, your set point is 10, but your secondary is 50 ampere. That means a high current is flowing. So that's why your PSM become 5. So that's it about PSM. I have taken a small example, just a 2-line example. Suppose a CT is rated at 100 by 1 ampere. That means in the primary, if it is 100 ampere, the ratio is 100:1. If the primary is 100, then secondary will be 1 ampere. And the setting for PS or threshold is given as 0.5 ampere. Suppose you want to set it at 0.5. 0.5 ampere means CT secondary 0.5 ampere. Anything crosses 0.5 should trip. Should indicate there is a fault, it should trip. That is my set point. 0.5 ampere in secondary means actually at what current I am setting? Because it is 100:1, that means actually is 50 ampere. If more than 50 ampere current flows, then it should trip. So in the CT side, in the secondary side, where we have reduced the value by using that CT, in that side, anything above 0.5 should trip. So my plug setting is 0.5 ampere. Now suppose a fault occurred, a huge fault occurred. Whatever the fault is, a dead short fault occurred, due to which the current in the CT secondary is 5 ampere. 5 ampere means your primary current is 100 times that one, that is 500 ampere. Due to fault, it increased to 500 ampere. So that CT secondary senses 5 ampere. So obviously 5 ampere is greater than 0.5, so it should trip. It will trip. So what will be PSM in this case? 5 divided by 0.5, which is 10. 10 means a high value of PSM, that is indicating your high fault. If more severe faults occur, then PSM will keep on increasing. This is very important, you remember this one. PSM higher will indicate fault is severe. Fault severity is very high. So now if you go to different types of, what are the different types of overcurrent relay we have? The first one we have is the instantaneous overcurrent relay. As the name suggests, instantaneous means, what is instantaneous? Means on time. Means at the instant, that's it. If there is a fault, at that instant it should trip. So there is no intentional time delay. We are not giving any intentional time delay here. But however fast do you want, there will be some time we will need to operate. At least of some few milliseconds, because CT will sense, then it will give. So however fast, you are not giving any intentional delay. There is no intention for delaying the time, but it will take some time. And it will have only pickup setting, does not have any time setting. So if you see a simple sketch diagram I have drawn, suppose this is a core of this fashion, and you have connected a current through which you are passing your CT secondary current. If the current crosses a particular value, then more flux will start flowing through this. Then this will become magnet. Once this magnet becomes, then it will pull this one. This will come below because it is now magnet, so it will pull this one. So once it pulls it, two contacts touches each other, and there is a spring which once fault is cleared, then it will go back to its original position. So there is no intentional time delay. You can see it here. If there is fault, it should come down, it should touch. That's it. So you can see the characteristics. The operating characteristics is always between your current. The operating is between your current and the how much time it will take. So it will be always asymptotic, like your fuse, because fuse gives the natural sense. More fault current, more fast. Initially it was peak up value, then it will start reducing inversely. Then after a particular value, it will be fixed, because that time is fixed. Whatever, then suppose whatever it will take some initially, it will take some time. That's why it is doing the inverse characteristics. As you increase the I, your magnetic strength increases, so it will come fast. But once you reach some value, then that magnetic value remains fixed. That up to this much, if it goes beyond this magnetic strength, then it will be more than my spring constant, so it will pull it. So after that, it becomes a constant. So this one you are not setting anything. So this is fixed. But this axis you can set it either in this direction or in this direction, because this is your pickup value. If your pickup value is more, then the graph will be more shifted towards right. And again, let me draw it. If your pickup value is more, suppose here is your pickup value, then the graph will be something like this. But if your pickup value is here, then the graph will be something. So you can change this flux setting. This axis you can change, but this one you cannot do. This axis you cannot change because it will be always remaining in same level only. So this is known as instantaneous overcurrent relay characteristics. Now next comes DT OC, definite time overcurrent relay. Here we will fix a value, current, 0.5 second, 0.3 second, 0.2 second, whatever. Before that, the fault will not be cleared. It will take this much time for sure. It can take little bit more than that, because of C2 will sense time, but you will give some intentional time delay there. So the issues a command of TRIF after a definite amount of time, that is adjustable. You can adjust that definite time after it picks up. Once it picks up, it will take some time. You will give that time setting. After that fixed time, it will be every time it will be fixed. Whatever the current is, it will be fixed. Up to that current, before that time, it will not trip. So it has both primary and it has both time setting and pickup setting. So you can see here the characteristics here. Again, this is your current, this is your operating time. You can see now the axis has both the flux setting. You can move it either in this direction, you can move it this direction, you can move it this direction or in this direction. That depends. This operating time you can change. This operating time you can change according to your time setting. This pickup value also you can change according to your flux setting. Now you can understand it can move up, down, left, right. Left, right depends on flux setting. Up, down depends on your time setting. So that's all for today.